So I'm going to talk about Java 16, which is coming in 3 months, and also on the 10th, so just in a few days, Java 16 will be forked from the main line. So from that moment on, no more new features, just small, just bug fixes. So this talk covers Java 16 and then whatever else we have time for, because I'm pretty sure there might be some time left over. We'll see. You can ask questions anytime, as we've discovered. I can observe the chat, and but if anything, like we also go to spatial chat afterwards. But if anything else is still open after that, you can always tweet at me, and I will gladly reply there. There's also a link to the slides, and I'm going to go ahead and post that into the chat so you can give it a go. I'm also going to, put that there because the slides are a bit confusing. They're two-dimensional, and the slide deck is huge. The slide deck contains everything new since Java 9 except for the Java module system. So it's a big, big slide deck. So if you're interested in anything that came after Java 8, just have a look at the slide deck, and we'll give you lots of information on most of these things. Ephemerellen, can I see it? I'm not sure what you're referring to with it. Okay, let's get going. Table of contents. We have a few language changes in Java 16. We're going to spend most of the time there. A few small updated APIs, actually. So we have time left, we go there. And if we have time left after that, we pick other things that look cool. So let's start with pattern matching. Bam, bam. This is where we're going to start. Pattern matching was first introduced in Java 14 as a preview feature. It was slightly changed in 15, slightly changed in 16, and now it's final. But the changes are minor, so it doesn't really matter. But it's final in Java 16. Pattern matching will be final. And the idea behind pattern matching is specifically the pattern matching for instance of that we get, that the existing instance of is kind of cumbersome, right? So let's say you get an animal here that you have to feed, but it doesn't have an eat method, okay? So slight oversight on the designer of that interface, doesn't have an eat method. So you cannot just call animal.eat. Now you have to figure out what kind of animal it is, so then you can like eat plants or eat meat. So the canonical way to do that in Java is to use instance of. You check, is animal an instance of elephant? And if it is, wait. Okay, great, sorry. You can see the slides. I was a bit confused for a second here, but I'm sure you can. So if animal is an instance of elephant, then you can safely cast it to an elephant and then call the elephant methods on that. And the same thing here for tiger, right? It's an instance of tiger, and then you cast it appropriately, and then you call tiger methods. And what you're doing here are three things. You're making this type test, you're converting the type, and then in this case, it's implicit, but sometimes it's explicit. You assign basically a new variable that you then want to use. And that is the old school way to do that. And since instance of pattern matching, since Java 14 or in Java 16 finalized, you can do this. You can put all of those three steps into one check. Animal instance of elephant, elephant, right? There's a variable name here. And what that does is it checks whether this is true. And if it's true, it declares a new variable of that type. And then it casts that instance to that type and assigns it to that variable. Right? So these are all three things at once. And everywhere where this where this condition is true, there you can use elephant and call elephant specific methods on it. Right? That means in this instance, tiger, you can use tiger wherever this is true, just like as with elephant before. So this is the new thing. This is the new thing you can do with instance of. But we call it pattern matching for instance of. So what about pattern matching? What's a pattern? What are we doing here? And we're going to see more patterns in the future. So it makes sense to get the basics down. So a pattern is, in essence, a test or predicate, some kind of check that is applied to a target. And then we have pattern variables where parts of the target, if it passes that test, are extracted. So let's have a look again at the instance of check here. We start with the variable, and this is the target for the pattern. Then we have our test. That's this part. Is it an instance of? And if it is, then we extract something into this elephant. In this case, in this variable. In this case, that means the casting that I described earlier. So you always have these three things. You have a target, you have a test for a target, and you have some kind of pattern variable or variables, could be more than one, where you're extracting stuff into if the target passes the test. And the last two together are called the pattern. And as I mentioned, we will see more patterns in the future. The interesting bit is that pattern variables are scoped wherever the compiler can prove that the pattern is true. So have a look at this. I want to see whether object is an instance of string. And if it is, I want to cast it into a new variable called string. If this is not the case, note the not. If it is not the case, I throw an exception. And that means that the compiler knows by the time we arrive on this line, this entire check must have failed. So this part must have been true. And that means the compiler knows that object is indeed an instance of string, and that's why I can use the variable string. Right? I mentioned that earlier. Wherever the pattern test was true, everywhere there the variable is in scope. We can also as well use it later in the same expression. So here I do the well if object is an instance of string, but I'm not happy with that alone. I need more. I want to test the length of the string. And because of this ampersand, this lazy AND operator, that means we only enter the second part of this entire Boolean expression if the first part was true. If the first part was true, we know once again object was a string. And so that means we can use the variable string here in the same expression even. And just as a counterexample, this does not work because if this is true, then I can use string. But if this is false, the compiler still needs to evaluate the second half of this OR operation, right? So AND, we only go into the second part if the first part was true. With OR, we might go in the second part even though the first part was not true. Actually, that's exactly the reasons why we go in there. Because if that part is true, we don't need to continue on. So in summary, you have this target operator, which is an instance of, and then a type and a variable, and it checks whether target is indeed of that type. If it is, it declares a new variable of that name and assigns it to the target with the cast. And you can use that wherever you can use that variable wherever the instance of type check is true. There will probably be more patterns, or many, I don't know yet. And we'll have to keep an eye out on how this will integrate with switch in the future. And what I'm going to show.
Hey, Nicolai.
Is, hi.
There is a question from Elliot. He's asking, is the pattern variable final?
Oh, I see it now, Elliot. Yeah, actually, that was one of the things that was changed. It had to be effectively final up until Java 16. So a change in Java 16 is that the pattern variable no longer has to be effectively final.
Got it. Thanks.
Okay, and what I want to show you now is how this could integrate with switch in the future. It does not yet do this, and it might not do in this specific way, but this is how this could look maybe in the future, where we can switch over variable and use type names as basically like a case label. So we can say, in case this is an elephant, then do this, but we also give it a variable. So, you know, we've talked through this. It's assigned to a variable called elephant with that's already typed to elephant. So something like that will likely be possible in the future, very likely even. Whether it looks like this, I don't know. Good. And that was it for pattern matching. As we mentioned, as we just demonstrated, I'm happy to take your questions. But in the interest of time, I'll just move on and you can just ask your questions anyway. I get back to it if it's necessary. Now let's do another thing, another feature that was introduced in 14, was then revised in 15 a bit, and now finalized in 16, and that's records. So for records, let's have a look like a run-of-the-mill Java bean. And like this one is really easy. It just has, it's a range. So it has a low point and a high point, like with a number, low number and a high number. And supposedly everything between those two numbers is part of the range. So, it's very simple. We create two integer fields, low and high. We create a constructor that accepts low and high and assigns the fields, and there we go. Although I forgot the accessors. So in this case, I need getters as well. Oh yeah, right. A good kind of bean thing should have an equals, because otherwise, like two ranges which both go from 0 to 1 would not be equal. That would suck. So I create equals. Oh yeah, right. Hash code. And like once you debug, you might want to see what range is just by looking at the debugger. So toString is necessary as well. So we ended up with a very, very simple thing, which is a range with a low and a high component, and it took 44 lines. And that has a bunch of downsides. The obvious and immediate downside, it's very verbose. I have to write a lot of code or generate a lot of code for that. The second part is it leaves a lot of room for error. That's not that obvious, but in the long run, it might even be worse than the verbosity. And the last one, once again, even less obvious, but even worse overall for the Java ecosystem, it's unexpressive. What I want to communicate here is this is a very simple thing. It's a simple range. It has low and high, and everything else is just standard. There's no fanciness. There's no complexity hidden here. It's really just that. But I cannot express that. And that means my colleagues, they can see that. They have to actually go through the code and check, is nothing fancy happening here? Is it really just a stupid bean? Enter records. A record is kind of like a class, but it's limited in one way and has some extra in other ways. So let's start. A record, you put record here instead of class. You define these components, low and high in this case, right? This looks like a constructor. But note that we're on the level of where we're creating the type, right? So we usually write public class range, and then this does not make any sense, and then we open the curly braces. But with a record, you put the components here. If you've done something like Kotlin, for example, you know that the syntax will be familiar to you. And what the compiler then does, it generates a canonical constructor, meaning a constructor that takes these two values and assigns them to the fields. It generates accessors, low and high, without the get prefix, which I think is a great decision, but that's just me personally because I don't like the get either way. So you get low and high, you get equals, you get hash code, you get toString. All of these with the default implementations that you would expect. So what's the deal here? How does this work? The mantra of records is the API for a record models the state, the whole state, and nothing but the state. Right? So that means a record has some state, and the API covers that and exactly that, nothing less and nothing more. That means you give up encapsulation. Right? If your field is an int, your accessor will be an int. If you rename your field, you rename your accessors. So you have this baseline of an API which is basically not encapsulated really, because it's immediately bound to all of your internals. So everybody using the API can couple to your internal state, but you get the API for free. So that means you don't have to have any boilerplate anymore, which I mentioned earlier is like the obvious downside of a 44-line Java bean. Once again, leaves no room for error. That's great. But what I consider to be most important is that it's more expressive. And this is also the way that this feature was developed. The way was, how can we express, we being us programmers, or like from the perspective of the JDK development team, a pattern that is commonly used outside in the ecosystem. How can we make that pattern simpler? How can we make it express that pattern immediately? A record, it's a simple thing that contains just a bunch of components and everything else follows from that. That is the idea. And now we want to make it possible to express that idea. And once it is possible to express that idea, the no boilerplate part is a consequence of that. Of course, it's an intended consequence. It's not coincidental. But it's still a consequence of another decision. So the goal is not reduce boilerplate, at least not directly. The goal is make Java more expressive. And this is what records achieve. Now there are details hidden here. And we're going to look at the list of details, but we're not going to go into the details. because I want to cover more ground with you. I think that would be more interesting. Oh, Sanjay asked whether I can show records before and after. Well, yeah, kind of. I kind of did already. It was so inconspicuous that you didn't see it. So this is my Java bean, right? 2 fields, constructor, 2 accessors, equals, hash code, toString. That's all in the same class. All of that code that I just showed you, 44 lines in total, is this. This is the after. We're done. This is the same 44 lines in 1 line of code. So that would be the after one. You might not have spotted it because it was like so short, but there you go. That's the after example. If you want to stick around, I can probably link to you. Do I have them online? I'm not sure whether I have my record experiments online already. But anyway, like if you ask me afterwards in Discord, on Twitter, or in the spatial chat, I can surely find a blog post or something that goes through these steps, so you can take a look at it in reading. In writing, sorry. So let's talk a little bit about the details of records. As I mentioned earlier, records are like classes, but limited in a sense. So you cannot use inheritance, meaning you cannot extend other classes, and you cannot be extended by other records. So a record is implicitly final, and records can never use the extends keyword. All the component fields are final. That means they can never be reassigned, right? If your component is something immutable, like an int or a string, then the record becomes effectively immutable. And you cannot have additional fields. You cannot have 2 fields up there in the record declaration and then add additional fields, because then they would not be part of the API, right? And then you would break that deal about records. So these are the limitations: no inheritance, final component fields, and no additional fields. But you can customize them in tons of other ways that you would be used to. You can override constructors. You can add constructors or static factory methods. You can override these accessors, right? So if you want to have low or high return something slightly different, although we get into dangerous territory there, because again, the API should model the state, you can do that. You can add additional methods. You can override equals hash code to string if you need to. You can implement interfaces, which makes them very interesting, right? So you can have comparable records very easily. And you can make them serializable. And the good part about this is, if you do any of these things, if you want to diverge from what a record gives you as a default, you can do that. And the resulting code will basically just contain those special parts. If I look at a record, I can immediately assume, okay, this record has 5 components. So constructor with 5 fields, with 5 parameters, it will assign it. Equals uses all of them, hash code uses all of them, toString shows all of them. I get 5 accessors. That's my basic assumption. And wherever that is not true, like maybe you want to have an equals that just uses the ID, or maybe you need to add additional things, like you need to implement interface, that's the only thing that I will see in code. So all the default stuff is assumed, and all the extra stuff that I have to pay attention to as someone reading that class, that's the thing that you put in code that I can immediately read, and we can clearly communicate where we diverge from this very sensible default. I have examples for each of these, so how they can be customized, right? So if we go here, we can see how to override constructors and what the canonical constructor is. But in the interest of time, once again, I want to skip that, so we have more cool and fancy things to look at. Because what I want to show you now is sealed classes. You can see that there is no circuit number behind this. By the way, I don't know why, but my font puts the double-digit circuit numbers, not all of them. The 10 is still the right way down, but the other ones are all like 90 degree. I don't know why. Sealed classes don't have a circuit number behind them. That's because they've been introduced in Java 15 as a preview feature. There's still a preview feature in Java 16. So you can use them. Yes, so Andrea, Elliot, so both of your questions, so let me answer both of them. Records were introduced in 14, just like sealed classes were introduced in 15, and you can use them as a preview feature. So you would have to use an enable preview flag. I'm going to quickly dropped a link to a blog post that I wrote about that. The one with the popcorn, there it is. It explains what preview features are. So you can take a look at that, how you can unlock them. But that means they are in the language. You can use them, but you have to jump through a few hoops so you don't accidentally use them, because they still might change in the future. Records came as a preview feature in 14 and are finalized, standardized, fully fledged, usable in Java 16. Seal classes came in 15, and you can now use them as a preview feature. Elliot, are records already well supported by serialization libraries? No. I mean, look, like to really support records, you need to speak Java 16, and not many libraries do that yet. I mean, you can have a multi-version jar multi-release jar where you target, where you have code in it that only runs on the specific Java versions. But so the only example that I know, and we can quickly go into that because I have it here, the only example I know is Apache Johnson. I know that they have, is that a link to the project? If you look for Apache Johnson and JSON-B and records, those three terms, I think you will find the blog post that explains how that they already support this. But it will take a while for them to pick up support, I guess. You know, just because it's easier to support features that you baseline against. So if you write a library that baselines against Java 8, that requires only Java 8, you can support Java 16 features, but it's a lot of extra work, and not many people do that. No, Java 17 is LTS. It's 11, 17, 23, 29, and so on and so forth. Okay, so let's do the last thing. Let's do sealed classes. Well, maybe the second to last, but they're pretty cool. So sealed classes. Let's take a step back before we talk about the feature, and let's spin up a hypothetical case. Okay, let's say we're modeling a domain, and many systems have like central abstractions. Maybe you have staff and customers. You have specific kinds of delivery mechanisms. Maybe you're writing a geometric library or a rendering library, so you have different kinds of shapes. And it's common that you use polymorphism to reuse code and attach functionality, right? So let's say you have shapes, and you usually want to say, okay, I want to compute the area of a shape, so then my shape interface gets an area method, and that's how we usually do that.
So, hey, Nicolai.
And that's fine. Yeah.
There is another question. What would be the minimal JVM version target for records?
That's an interesting question. I would just say 16, but since you could potentially just compile records to classes that then just look like normal classes to the JVM, you could make an argument that you could compile it to older versions, but I would be surprised if that works. I'm pretty sure that you would have to use Java 16 as a target to compile against. I would be surprised if for anything else. I'm not 100% sure though.
Okay.
So right, so we have these central abstractions, like let's stick to shapes, for example. Now, if many subsystems use our shapes, they have many different requirements for our shapes. So there's this certain risk that we start attaching a lot of not really related functionality to shapes just because they're used all over our system. There would be feature creep, right? You end up with interface with like 20 methods that are partially like unrelated to one another. What you could also do is you could have subsystems that implement their own handling. So let's say you get a shape or you get a staff, and then you figure out, okay, for each subsystem of staff, each subtype of staff or each subtype of shape, I want to do something specifically. And the normal way to do that, the normal OO solution to that, is the visitor pattern. Right? That's what the visitor pattern is for. You get an instance of a type. You know there's a bunch of subtypes. You want to create an operation that works for each of these subtypes, but you don't want to attach the operation to the supertype. That's what you use the visitor pattern for. Just like the exchange between can't say his name and how do I get a password to watch. Okay, anyway, yeah, we can do that. We can keep the question to the spatial chat. So anyway, so this is what the visitor pattern is for. But why do we do that? It makes sense to take a step back and think, why do we use the visitor pattern? Because there are situations where the types variations are actually finite and known. We know in our subsystems, we have circles and rectangles and no other shapes. We have employees in freelancer and no other staff. That's not uncommon, right? It's actually, I would say it's maybe the more common type, that you don't have various implementations. Well, maybe it's not the more common type, but it's very, very common that you don't have various implementations coming up wherever, but that you're pretty exact idea of what your implementations will be. And if subsystems can rely on that, if you know that we only have these two shapes, you can just abandon the entire visitor pattern and just use instance of. Okay, we don't do that though, because it doesn't look very OO, and we've been told it's less maintainable. And the reason for that is that the compiler can't help you there. You might know that there's only a circle and a rectangle shape and no other shapes, but the compiler doesn't know. If you add a third shape, who knows what happens? The compiler will not give you a warning on error, so you're on your own there. So even if you are in the specific situation that you know there are only a certain set of implementations of a shape, you cannot really benefit from that. So that's right. That's where we are at that step. And now it makes sense to talk about inheritance and what the compiler understands of inheritance. So what can you do if you have a type or a class? You can say it's final and nobody can extend it or inherit from it. You can say only package visible classes can extend. You can do that by making the constructor package visible, which is basically a little bit of a cheat there. Or you can say, just make my class public. Everybody can extend my class. And for interfaces, there is no choice because they can't be final and they cannot have a package visible constructor. But in all of these cases, as I mentioned earlier, the compiler doesn't know which implementations there are. This is not expressed for the compiler. And this is finally where we come to sealed types. I've been working towards this for the last couple of slides. This is where the new feature comes in, sealed types. Because with a sealed type, we can express a limited kind of extensibility. By that, we express that only specific types can extend a sealed type, and both a developer reading that and the compiler parsing that will know which types they are. Here's an example. This is my interface staff. So far, so good. But I do two things. I add a sealed in the beginning. I'm sealing that interface. And then I have to specifically write down who can implement that interface. I list two types here, employee and freelancer. So only these two will be allowed to implement staff. And nobody else will be allowed to do that. If you do that, if you try to have a consultant that implements staff, you get a compiler error. So up here or down here, I forgot where, but somewhere you get a compiler error. Actually, down here, definitely. I'm not sure about up there. So you do get a compiler error when you try to add an additional implementation. You just can't. And that means you can rely on that there will be no other implementations because the compiler won't permit them. But you also know that all the implementations that exist are known to the compiler. And if we go back once again to the example that I showed earlier, where I used the switch statement over an instance, and then as case labels, I use types, where I want to say, in case that staff is an employee, do this thing. And if it's a freelancer, do that thing. If we do that, and if we combine that with sealed types, we get a very interesting property. Because now the compiler can check exhaustiveness. The compiler knows, well, this staff is of type staff. There are only two possible implementations of that. Both of them are tested here. So the compiler understands that these are all the cases that you have. And if you would ever go back to staff and admit a third implementation. All of these switches would give you compile errors, which is great because we just lifted something from the visitor pattern into the language. That's exactly what we use the visitor pattern for. Remember, you have a visit method on the interface, and then each implementing class has to pass this itself like this to the visitor, and then you have this chain where you have to fix compile errors, which will lead to all the visitor implementations. So you cannot add a new type without getting compile errors from the visitor pattern, and that's on purpose. So you make sure that all of these treatments of this type actually take care of the new subtype that you just created. And the same thing happens with seal types. You permit a third type, in this case, and then it compile errors everywhere where you handle that type. So this basically replaces the entire damn visitor pattern. Okay, now there's a bit more here about how, like, there's a final and then there's non-final and then there are a couple things that you could look at, but we're not gonna, because we're straight out of our 30 minutes. So what I want to leave you with is, well, first of all, I wrote a book about the module system, but that's beside the point. I'm NipafX. You can find me on Twitter, that's the bird, on YouTube, on Twitch, and on GitHub as well. And on nipafx.dev, and also in the spatial chat right now. So we're going to go to the spatial chat now, and you can ask me all the questions you have there, and I'm going to do my best to answer. Other than that, in case you don't follow us to the spatial chat, I wish you a great time and a great conference, and I'm sure I'll see you around somewhere. Bye-bye.